Friction is a force of resistance between two surfaces, and these surfaces can be solid, liquid, or gas. On Earth, we often think of friction acting between us and the ground or other solid surfaces because they resist a lot of our motion. But don't get it twisted. Water is a surface that provides a great amount of resistance to motion. If you've ever been swimming, you can feel the water pushing against you, and other liquids can as well. Gases can also provide this resistance, and air resistance is an incredibly important factor to consider when we're looking at athletics and aeronautics. For our demonstrations today, I'll be using these two blocks. The small one is roughly half the size and half the mass of the large, with a smooth and a rough side, and we have this spring scale to measure our newtons. The first factor to think about when we're looking at friction is bumps, because bumps cause friction. All surfaces have some bumps, and when you have two surfaces or two objects moving in opposition to each other, those bumps between them get sort of stuck on each other, and the more the bumps get stuck, the more friction that you have. This then causes motion to slow down. So here you can see my first little block here as I pull on it with the spring scale. I get a half a newton of force is what it takes to pull the block across this very smooth, not bumpy board. And this larger block, because it's heavier, is 1 newton. When I pull these blocks across a bumpy surface, you can see that the newtons required go up here, and the newtons required to pull the larger block also increase, because of these bumpy surfaces getting caught on each other. So, are bumps all bad? I mean, this seems like friction is just very counterproductive, right? But that depends on the situation. So, bumpy things are grippy, which is necessary for a lot of things to happen in our world. Like when we walk, we push down against the ground, and the bumps allow us to kind of catch with that motion. If we wanted to go rock climbing, the bumps on those rocks really help us to be able to grip, just like our tires do. They're bumpy surfaces, and roads are these bumpy concrete surfaces, so the tires and the road can grip. Chickens have bumpy feet for grabbing onto branches, and dogs have bumpy feet for while they walk as well, so they don't slip all the time. People also have bumps. Our fingerprints are grips, and these Oreo cookies have bumps so that our fingerprints can grab the bumps and we can dip them in milk. Coins have bumps on the side to interact with our fingerprints, and so do rock wall grips, so that we can climb up and not lose our grip. Basketballs are super bumpy so that we can grip them. And so are the handles on our tools in the garage and in the kitchen, so they don't fly out of our hands and we don't hurt ourselves while we're using them. Bicycle grips are super bumpy, and so are car steering wheels. So grip isn't all bad, but sometimes those bumps can slow you down. Like if you're trying to pull something across the grass, it just doesn't pull very easily. Now, decreasing grip makes things slippery, which is cool if you're going down the slide, right? We want things to move and slide easily. Or if I wanted to slide across the floor, my grippy shoes aren't going to do me much good for that. But if I have my smooth socks, it's a lot more enjoyable to have that sliding fun. Going snowboarding on the snow is smooth and so is the bottom of the snowboard. But if we go sandboarding, we have to put wax on the sandboard because the sand itself is a lot more bumpy and gritty. So drag can be decreased so that we can go faster, which is why the edges of our cars are smooth. Increasing mass increases friction because the extra mass causes the bumps between the two surfaces to get pushed together, and they get stuck on each other more kind of aggressively, which causes more resistance. So the empty block took 1 newton of force to move, but when I add a 1 kilogram weight, the carpet kind of gets pushed into the table, and it's 4 newtons of force to move it. The third factor is surface area, and basically larger surfaces also are going to have more bumps coming in contact, which is going to cause more friction. Smaller surfaces are going to have less bumps in contact, causing less friction. So if I have 2 pieces of paper, same mass, and I crumple one of them up, and then I drop them from the same height, we'll notice that the unfolded paper takes a lot more time, and the crumpled up paper falls straight down. The flat paper has a larger surface exposed to the air, so there's more air resistance, which slows its motion. But the crumpled up paper has less air resistance, which causes it to fall easily. More surface area causes more drag, so let's see some examples. Old cars were really flat and boxy and had a lot of surface and resistance, but newer cars are smoothed out so that the air flows over. If we swim in normal clothes, there's lots of resistance, but swim caps, like tight suits and streamlined swimming, helps us to move quickly through the water. If you were to go jogging in the mountains with loose clothes, it's all good, but in a race, you gotta have spandex. When swimming with fins, the larger surface allows more surface of the water to push against the fins so that the person can swim faster. And when we go skydiving, the parachute's watered up in the bag, but when it opens up and spreads out, the surface of the air rubs against it to slow the person down. Moving objects have less friction than static objects because with the still objects, the bumps are kind of more settled in and stuck together. As you can see here, it takes a lot of force to get this block moving. Oh man, like 9 newtons. But these moving objects, when they're already moving, the bumps haven't settled in yet, so it's a lot easier to keep the thing going with less force, like 6 newtons once we get the block going. Last 2 factoids: friction causes things to heat up 64 before we start the sander, and after 15 seconds of sanding, 72 degrees, because the surfaces rubbing together makes things heat up. So if you want a cool friction reducer, try wheels. It takes like 6 newtons of force to move this block before we put it on wheels, but when we add our friction reducer, zoom, 2 and we're good to go.